Hello, dear Chair and ladies and gentlemen. Actually, I have to make a point that Dr. Abdul Hassanpour couldn't make it because of the visa issues. So I'm the member of the research team, so I will be going instead. My name is Hadi Mustafa. I'm a medical doctor and researcher currently in Vienna University.
Yeah, well.
Problem with the... Okay.
Okay.
My study title is the animal cerebrolysin spinal cord injury model, and using systemic cerebrolysin in the neurogenic to improve the neurogenic bladder. So I'm going to skip these sections to this illustration. This is an illustration that I did to just sum it up, but I don't want to get too specific. Control of the micturition center is from different centers: the pontine center in the brain, the cortical micturition center, the spinal micturition centers that you can see here that I've shown. And let's get to cerebrolysin. I have lots of tongue twisters in this presentation. So the first, cerebrolysin is used in most of the neurological conditions as Alzheimer's or spinal cord problems, and also in Parkinson's disease. And it's a factor that is a low molecular weight protein that it's derived from the brain of pigs, and it consists of some growth factors that help on the brain cells to to develop and for the axonal regeneration. So there are lots of studies that have studied the use of cerebrolysin in the spinal cord injury, but what we did was to use it to study the neurogenic bladder and its effect on neurogenic bladder. We had two groups of mice that we studied in a acute phase and a chronic phase. In almost 10 groups that we also had a control group and a sham group that we only did the spinal cord injury and the dissection. And then we used different doses of cerebrolysin in each of the groups, and we studied in two sections, as you can see, an acute phase and a chronic phase. And what we did was to transfuse cerebrolysin in the acute phase of spinal cord injury after making the dissection of the spine, and in the T9 level actually, and the other groups after we did it with a 4-week delay. And after 4 weeks, we injected the cerebrolysin. You can see the surgical procedure of the dissection that we made. And afterwards, we have reported in this study with two outcomes. The first outcome that we studied was the functional changes in the bladder that was published previously, but this one that I'm going to present you is the changes in the most of the factors and brain growth factors. So you can see that there has been these are the different dosages that you can see, but it's a bit tiny, but different dosages of cerebrolysin and its effect. As you can see, by the increase of dose, the expression of GAP43, which is the growth associated protein 43, it has effect on the growth of, and also growth of the neurons and axonal regeneration. And these are some of the other studies. And also we had a rise in PERK and ERK density in the spinal cord. So it has kind of a linear relation, and as dosages of cerebrolysin increases, there were higher doses of these factors. As the interpretation of result, what we found out was that the 2.5, the dosage of 2.5 milliliters had, and the 5 milliliter group had higher response, but we had some mortalities in the 5 milliliter group. So that's why what we concluded is that the optimal and the best dosage is somewhere in between the 2.5 and 5, because as you saw in the images, the 5 milligram had higher rate of regeneration. And that's it. Thank you for your attention.
Okay, so some points of clarification.
Yes.
What kind of spinal cord injury did you do?
It was a total. It was from the T9 section. It was a complete section.
Okay.
So we didn't use hemisection, just a complete section from the T9 level. And I showed also the images of the surgery.
Well, you showed the exposure.
Yes.
Yes, but could have dropped a weight on it after that.
Yeah, because of the lack of enough time.
So the other question is what section of spinal cord did you measure GAP43 expression?
We got it actually T9 because we wanted to just to cover all the. This was because it was higher than the level of the bladder control, so we wanted to cover all the sections. So the dissection was done in the T9 level of the rats.
For the measurement of proteins? When you measured proteins, you measured proteins at the T9 level? Or the L6 level?
No, I mean the dissection.
Yeah, no. So we're past the dissection, sorry. You said that in the brain, or in the spinal cord, you had changes in certain substances.
Yes, yes.
Where?
Can I refer this question to my supervisor? Because, thank you.
We have done it for all. Actually, we, after the transaction at the level 9, we have done this study in the all lower limits. Yeah. Yeah. No, not specifically.
We all need to be involved in the discussion, Matt.
Yeah, exactly. Yeah.
And I would just like to clarify a bit. You're putting in effect a cocktail of growth factors and trophic agents. Is this really that you're speculating that this cocktail might be beneficial for recovery? The hypothesis behind doing this work?
Well, as I said, we have reported the functional changes before, and that was quite in the same direction with the what changes the growth factors that we saw in this study. So that's this hypothesis.
And I can just add something. Now, clinically, cerebrolysin is using for some cerebral lesion in neurology, like Parkinson's disease, Alzheimer's, and some other diseases like stroke. So our hypothesis got from that way, if it's effective for such disorder clinically, maybe it can have some effect for spinal cord injury as well. So we wanted to focus on neurogenic bladder in spinal cord injuries with that hypothesis.
Yeah, super. Okay, quite a challenge. We wish you very good luck for ultimate success.
Thank you very much.
Thank you very much indeed.
Thank you.